Oh, JT. Okay, got it. Bennett, right? Yeah. Bennett. Yeah. Okay. All right. So let's get started from the current slide. Well, there we go. All right. Any questions for anything we've done so far? All right. We are on page 147. It's chapter 3, polynomials, 3.4, factoring, greatest common monomial factor. And can I get your name, please? Say again? What's your name, please? CJ. TJ. Oh, CJ. Got it. Got it. Okay. You probably said that. I couldn't hear. Okay. Try again. Chapter 3, polynomials, 3.4, factoring, greatest common binomial factor, example 5. Okay? And I believe example 5 was not given in the text. So let's back off. And let's see. Yeah, we'll do it here under 4. All right. Okay. Let me make sure example 5 isn't going to be done. No, it wasn't. So I was right the first time. All right. Let me get the pen set up and we'll go. Okay, example 5. X squared plus 2x minus 3x minus 6. How would we factor something like that? Grouping. Okay, very good. Okay, now, and I think in the last, no, this is the first one like this. When you have a plus after the first group, then you can exclude the plus. But when you have a minus, you have to include the minus. Okay? So you have to include the minus in the grouping. Now that looks like a factorization. It's not, okay? Just because the parentheses are next to each other, that doesn't mean you multiply. Those are just grouping symbols. What do we do with the first group? Factor out an x. What's left? X plus 2. In the second group, negative 3. Excellent. And what's left? X plus 2. Very good. Y'all are good at this. Now what? Say again? Okay. Factor out the x plus 2. It doesn't matter which order you do. And what's left? X minus 3. There you have it. Okay? That's the factorization of this one. And if you want to check it, it's real easy to check. Just plot x squared, there it is. Minus 3x, there it is. Plus 2x, there it is. Minus 6, there it is. Yeah. You can always check your factorization by multiplying, because factorization is like division, so multiplication is a good check for it. Any questions on that? Okay. Let's clear the ink and do example 6. Here's the next one. AB squared minus 4b squared plus 3a minus 12. Okay? What would you do on that one? Group them. Anytime you have an even number of terms, more than 2, then usually grouping is your first step. Okay? So let's group the first 2 and the last 2. Here it's a plus sign in between, so you can leave it there so you don't think that's a factorization. What do you notice about the first group? Common factor of b squared. Factor that out. What's left? A minus 4. And in the second group, plus 3. And what's left? A minus 4. And now what? Factor out the a minus 4, and what's left? B squared plus 3. Excellent. Okay? Now, we always ask ourselves, can we factor that any further? And the answer for a while now is going to be no on every one of them because we haven't done any like that. But the thing is, you can't factor that any further. And you could go back and FOIL it and check and see if you got the right answer, but I'm convinced we did. Because they happen to get the same thing the book did for them. All right. Now, that was just going too smoothly, wasn't it? Yeah. Well, guess what? A little wrinkle. 4a squared minus bc squared minus a squared b plus 4c squared. What would you do to that? Group it. How would you group? Okay, the first two and the last two. Okay, now what? Whoops. Huh? A little louder? Can't factor it. No common factors there. Give it up, hang it up, not factorable? No, 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 no. What can we do? Well, let's ungroup. That's a real common math word, okay? What do you think we ought to do? Okay, rearrange the terms that do have common factors. And what do you see? 4a squared minus a squared b minus bc squared plus 4c squared. Now, you might want to do a little more rearranging, but we can live with this. Now what? Group. Not group, okay. What do you notice in the first one? A squared. What's left? 4 minus b. Second group. A c squared. This time I'm going to get you let you get away with it. So plus c squared. Okay, I'm looking ahead. So what's left? Say again? Negative b plus 4. Okay, now my question to you. What next? This is indeed the same as that. It's just in a different order. This is 4 minus b. This is minus b plus 4. So those are the same terms, so you can factor it out. Okay? That's why I said it may have been a little better if you had rearranged this and let off with your 4, just like we had up here, plus 4c minus bc squared, 4c squared minus bc squared, then it would have looked just like this. Okay, so what do we have? 4 minus b is a common factor, and what's left? A squared plus c squared. And as tempting as it might be, don't even try to factor this. You can't. Later we'll see why, okay? But you cannot factor that. All right, good deal. Little bit of a twist in there. Sometimes you do have to rearrange terms. Okay. Now, this text, this is a fairly new edition. I hadn't noticed it last time I used it. It has on many of these, in fact, I'd say all of these examples we're doing, has on the margin another one called classroom example. Okay? And does your book have that too? Or it's only the instructor edition? It does have in the margin classroom example? Okay, my suggestion to you, as soon as you're out of class, and not in another class, and have a little bit of time, go back and do all the classroom examples that correspond to the ones we did in class. The sooner you do them after class, the fresher it is in your mind, the more likely it is you're going to be able to remember it and do it then. Once you do it yourself, see, Right now, many of you are participating. In fact, most of you are, I think. I think all of you are thinking about it. But when you actually put pen to paper, you're actually doing the work. Right now, I'm doing the writing. So the soonest you can do that, the better you'll get these implanted in your mind. If you can't remember how to do it, then bring that question to class next time. So as soon as you can, I wouldn't, unless you're going straight home, I wouldn't wait till you got home. I'd say find a nice quiet place, sit down and do as many of them as possible. Then later, or at that time, you can do your homework exercises too. But as soon as you can, do the classroom examples. Okay? That was a little paid commercial. Okay. All right. Any questions? Okay. All right. All right. This was the example, I didn't realize it, that we just did. Example 7. And they work it out too. And the first thing they did is rearrange, and they rearranged the best way. You know, did swapping several terms around. But you'll be able to see this if you watch that as well. That's one method. Here's another method, another rearrangement. This time they got the terms with 4's together and the terms with B's together, okay? And then did it that way to get the same answer. So as long as you do all the steps right, there's usually more than one way to do a problem. Didn't you hate that in school when the teacher insisted you do it his or her way? Okay? If there's another way to do it, feel free. As long as you get the right answer, fantastic. Okay? Now, using factoring to solve equations. Yes, that's what we're after. Where the rubber meets the road. This is what we want to do with our properties here, is be able to solve problems. Because guess what? You go to work for somebody, say you're coming to work with me, I'm not going to say, can you factor these things? No, I'll say, here's a problem, solve it. So that's where the real meat of this comes. When you've got an issue, how do you think through, work through, and get a solution? One reason factoring is important algebraic skill, it extends our techniques for solving equations. Every time we examine a factoring technique, we'll then use it to help solve certain types of equations. We'll need another property of equality before we consider some equations for which the highest common factor technique is useful. Let's say we have two factors. Here's a factor, there's a factor. Multiplied by each other equals 0. What's true about one of those two factors? It's got to be 0. There's no two numbers in the world that you can multiply together and get 0 as an answer unless one of those two is 0. There's no way. Try it. You can't find any. One of them has to be 0. And that's called the zero product principle. Can we conclude that at least one of those numbers must be 0? Yes. Let's take the property. Here's the property. They list it twice. Okay. No, they don't. This is just describing it. Along with the highest common factor pattern provides us another technique for solving an equation. Here it is. If A and B are any real numbers or entities, they don't have to be just real numbers, they can be expressions. If A, B is equal to 0, that's true if and only if A is equal to 0 or B is equal to 0. Can't have it any other way. So extend that, not just be real numbers, but any entity, any expression. If two expressions multiply together equal each other, one of those expressions or the other has to be 0. All right, so let's see if we can solve this. What would we do? Did I ask you before if I could use the question, what is the F word? I didn't, did I? Or did I? All right. When I ask that question in this class, if it doesn't offend anybody, in this class, guess what the F word is? Factor. All right? Yeah, wash your mind, okay? Now, so, in this class, the F word is factors. When I say, what's the F word? Guess what? Factor. All right. Clean it up, folks. Okay. So, what are we going to do? Factor. Good. And how do we do that? Now, if that's offensive to anybody, I won't use it. Anyone have objection to it? Huh? Yes, let's pull out an x. And what are you left with? 6. Very good. And that product is equal to 0. So guess what that means? Either x is equal to 0 or x plus 6 is equal to 0. Well, if x equals 0, there's a solution right there, right? How about the other one? Second? Yeah, it is. You're making fun of my writing, aren't you? Oh, yes, you are. I can tell. Okay. No, I always slash my zeros. Sorry about that. It's an old habit left over from the Navy. Also slash z's and do all sorts of weird things. What do we do with the second one? Subtract 6 from both sides, and what does that leave us with? X equal negative 6. There are 2 possible solutions. Let's see if they're right. Really easy to check, aren't they? Let's go to this, plug in x equals 0. 0 squared is? Plus 6 times 0 is? 0 plus 0 is? Yes, that works. How about this one? Negative 6 squared? 36. Plus 6 times negative 6? Negative 36. 36 minus 36 is? 0. I would say bingo, but you can't do that in California, in Alabama. Okay. Yeah, I'm just kidding, huh? Both of them work. Both of those are solutions. Okay? Those are your 2 solutions. Can I get a name, please? Huh? Michaela. Okay. All right. There you are. All right. Anyone else come in such a called roll? Okay. Yep, 2 solutions. By the way, little fact about polynomials. This is a polynomial, remember? That's what we're studying. Factoring polynomials, right? That's a polynomial. If you look at the maximum exponent in a polynomial, when you have it set equal to 0, that's the maximum number of answers you could have. You don't have to have 2, but you could have up to 2. If you find 2, you're through. There aren't any more. Occasionally you'll have polynomials that will give you 1 solution or 0 solutions, but you can't get more than 2. Okay? So we usually, if the exponent is 2, maximum exponent is 2, we usually look for 2 solutions. If we can't find them, it's fine. But if you have to get 2, quit. You've got enough. Okay? Now let's watch them do it. I bet you they don't do it as nice as we did. Okay, let's see. All right. Guess what the first thing they do? Write down their equation again. Good move. Okay. Then they factor. And because you have equals 0, then you can set the first factor equals 0 or the second factor equals 0. The 0 product principle. The first one, that gives you a solution. X equals 0. The second one is subtract 6 from both sides, you get x equals negative 6. Understood? All right, those are your 2 solutions. Now, I think the book usually then writes it in set notation. I don't care if you write it in set notation or not. If you want to, fine. Thus, both 0 and negative 6, once you check them, you know they satisfy the original equation, so the solution set is that. I'm perfectly happy with that. That says the same thing to me as putting it in set notation. But if you like to put it in set notation, go for it. And by the way, that back of the book will probably give the answers in this, so know what that means. Okay? Why does the back of the book do that? This takes less room for the typesetter than that does. Okay? And the typesetter is just as lazy. No, I mean, we won't talk about that. Okay. Any questions? All right. They're skipping example. All right. This is why we had an issue, okay? Because they didn't just skip them. This new edition has more examples than the old one did. That was example 5 in the old thing where my PowerPoint comes from. The new edition, that's example 8. So those we did before were new examples. Let's do example 9 then. So let's Go back here and do example 9. Solve this one. A squared minus 11 is equal to, I'm sorry, I can't read, is equal to 11a. Do we have any techniques for which that will work? Can I get your name, please? Sheffield. Huh? Sheffield. Okay. I'm hard of hearing, so. You are Jalen, right? No, Jay, right? Okay. Good deal. End of the alphabet, really coming in strong there. Bunches in a row. In fact, I'd say everybody's coming in strong. We're missing Kenesha, Decime. That's all, folks. Way to go. Good attendance. Either of those here? Okay. All right. All right, here's a suggestion. Divide A from both sides. Let's see what happens if we do that. Okay, let's divide A from both sides. And what would we have left? A is equal to 11. There's your answer, right? Now, what did I just say about maximum exponent equal to 2? You expect to have maybe up to 2 solutions. We only have 1. That could be true, or it could be we're missing one. So is there another way to work this problem that might reveal if there's another answer or not? Second? Subtract what? All right, let me go back and write it down. A squared equal 11a, and what are you suggesting? Subtract 11a from both sides. What does that give us? A squared minus 11a equals 0. Why would we want to do that? Because now we can use the zero product principle. We couldn't the way we did it the last time. Let's see what we get this time. What's our next step? Factor. Okay, good deal. What do we factor? A times A minus 11 equals 0. Now what? Either A equals 0 or A minus 11 equals 0, which would give us, add 11 to both sides, and you get A is equal to 11. All right, we agree here. We missed A equals 0. How do we miss that? You did something totally illegal in most states. You know what that was? You divided by 0 here, didn't you? You can never divide by 0. But by dividing out your A, you lost that solution. Okay, so usually a better idea is to set it up in sort of a standard form. The quadratic or the higher power thing is equal to 0. You do that, then factoring should reveal most of your answers. Doing this, as soon as you divide by A, then you have to say A can't be 0 because you can never divide by 0. But A is equal to 0, that is one of your solutions. So that's why it wasn't a good idea. You got half the answers, but not both of the answers. Okay? Better idea to do it that way. Good deal. All right. Any questions on that? All right. Let's clear those and go to example 10. 3n squared minus 5n is equal to 0. What do we do in this one? We all got it in the form we want, equals 0. That's good. Now what? Factor out an n. What do you have left? 3n minus 5 equals 0. Now what? Either n's equal to 0 or 3n minus 5 is equal to 0. Where do we go from there? That's the solution. Add 5 to both sides, and that gives us 3n is equal to 5. Divide by 3. Excellent. You can't divide by 3. That's legal in all states, okay? And that gives us n is equal to 5/3. All right. Whoa, can we have fractional solutions? Sure we can. Perfectly good numbers. We love our fractions, don't we? Sure we do. Okay. Now, I forgot to do this on the last one. I think you probably did it mentally. Let's just check our answers. N equals 0, does that work? 0 minus 0 is 0. Yeah, that works. Oh, yeah, we wanted to do this one, didn't we? What is 5/3 squared? Again? 5/3 squared. Okay, yeah. You square first, then multiply by 3. Okay, remember rule of order of operation? Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her, okay? That's fine, okay? So please is parentheses, we don't have any. E is exponents. Always do the exponents before you do my dear, which is multiplication and division. So do the exponent first. So 5/3 squared is 25 over 9 times 3 would be just 3 into 9. 3 times, so it'd be 25 over 3, right? You buy that? Okay. Let's work it out. Okay. All right. 3 times 5/3 squared minus 5 times 5/3. Right. That's what we do. Plug in the n everywhere we see an n. Right? Okay. Supposedly, this is equal to 0. We don't know if it is or not. That's what we're going to check. Okay. You do 3 times 25. Okay. I'm not going to multiply the denominator. I'm just going to leave it as 3 times 3. Is that okay? All right. Minus 5 times, well, let's go and multiply that one. Ooh, get out of there. Okay. All right. Let's multiply that one. 5 times 5/3. 5 times 5/3. 25 over 3. This is 5 over 1, isn't it? When you multiply the numerator, multiply the denominator. Don't be multiplying the numerator by the denominator. That's not fair. Okay? All right? Okay. Everybody see why that's 25/3? Okay. Is that equal to 0? Okay. Well, this 3 will divide into one of those 3's, right? 3 over 3 is 1. Get rid of that one. And what do we have? 25/3. Yes. Sure. Yeah. Minus 25/3 is, guess what? 0. Bingo. I mean, we can't say that. Okay. All right. Got it. All right. Any questions on that? I think checking was harder than working the problem, wasn't it? Okay. It's usually a good idea to check. I just always like to make sure I got the right answer, so I like to check them. Okay, let's go to example 11. All right, this is another strange one, isn't it? Okay. We love strange ones. That's why you signed up for me. No, I didn't. Okay. All right, here we have 3ax squared plus bx is equal to 0. And it says solve this for x. Okay? Why is this a little strange? It almost looks like we have 3 variables. Okay? Well, guess what? We only have one variable, x. The other 2 are just unknowns, which is really what variables are too. But it says solve this for x. So we're not going to worry about a and b. We're just going to solve for the x. Now, what does that mean? What would we do? Same thing as before. Second? I can't hear. Okay, isolate the x, and how do you do that? Well, let's factor, okay? And what would that give us? X times 3ax plus b. That's equal to 0. Now what? A little louder? I hear mumble, mumble, mumble. Okay. Okay, either x equals 0, you set each of the factors equals 0. Either x equals 0 or 3ax plus b is equal to 0. This is already a solution right there, right? This next one, though, now we isolate the x. You were one step ahead there. We want to isolate the x. So how are we going to do that? Subtract b from both sides. Okay, just treat it like a number. We don't know what it is, but okay, what does that give us? 3ax is equal to negative b. And now what? Divide by 3a. Okay? That gives us x equal minus b over 3a. Now, one thing that we have to then assume, a can't be 0. Okay? Well, if a were 0, this would be a real simple problem, wouldn't it? If a was 0, then the first term doesn't exist. So you just have bx equals 0. Divide by b, x equals 0. Unless, of course, b is 0, and say b or plus 0, 0 is equal to 0. Yeah, okay. Not very interesting, but it all fits. So this is your answer as long as a is not 0. And that's what it meant. Solve for x. This one was obvious. The other one, yeah, that works too. You want to plug that in? Check it? Oh, sure you do, don't you? It's a little more difficult, but it's doable. Okay? It would be 3a times, when you square this, you get a positive b squared over 9a squared. Well, the 3 will go into 9 3 times, and the a will go into a squared 8 times. So you have b squared over 3a plus b squared, minus b squared over 3a, and that adds to 0. So it's not too bad. Okay? Write it out, you'll see that does happen okay. But again, almost checking is almost harder than doing the other. All right, any questions on that? All right then, let's move on to the next slide. It'll finally get, yeah, there it is. Solving word problems that involve factoring. Yes, we love doing our word problems, don't we? Our favorite thing to do. Okay? Here it is. The area of a square is 3 times its perimeter. Find the length of a side of the square. How would you approach that word problem? Yes, you should. Okay? How? In most problems like this, I suggest draw a picture if at all possible. So what picture might you draw? A square. That sounds like a great thing to draw. Now my squares are pretty ugly, but I'll do the best I can. There's a square, okay? Now, not much we can do with that, but next thing I do when I have a word problem, usually, once I've drawn down as much as I could, I think that I want to look what we're looking for. What is the question here? What are we looking for? The length of a side of the square. That's usually a good thing to list as your variable. So you pick a variable, any variable you like to represent that length. What do you want it to be? No, 4 is a number. I said a variable. Say again? A. Okay, A is a good one. So what we say is let A equal the length. You don't have to write all this, but I'm going to do it for this time. I can't spell either. Of a side of the square. You're making fun of my writing, aren't you? I can tell. Okay. Let A be, okay, let's label it on our figure. Okay. So this is A, that's A, that's A, and this is A. It's a square. All 4 sides are the same, right? That's what makes it a square. Not only that, the 4 angles are the same too, and the right angles, so that also makes it a square. We're not really interested in that yet. Not quite. Now, let's go to the first sentence there. What we need to do is translate the English into math. It says the area of a square. What is the area of a square? Say again? No, I believe that's the perimeter. The area is what? Okay. You're jumping ahead. Okay. What's the length times width? What's the length of that square? A. What's the width of the square? A. So guess what the area of the square is? A squared. Look at that. We translated that into English. Is. How will we translate is? Equal to. Very good. So translate the area of a square, that's A squared. Is equal to 3 times its perimeter. What's that? Okay. 3 times, I know what 3 is. 3 times, and what's its perimeter? You just gave it to me, didn't you? No, that's the area. Say again? A times 4, 4A, okay? Now here's how I think of perimeters. I don't know if you don't want to remember. Let's just say, pick a corner, any corner. Which corner you want? Upper left, upper right, lower left, lower right. Pick a corner. Say again? Top right. Okay, everybody gave it different. It's top right. Here, we'll start here. Let's walk around the square. How far did I walk? That's 2A. Okay, walking around the perimeter, around the square, I walked 4A. I had my Fitbit on, I could tell. Okay, so that's the perimeter is 4A. So there we have our equation. We translated the words, the English, into algebra. Area of a square, A squared, is equal to 3 times the perimeter. The perimeter was 4A. Okay? What does that tell us? A squared is equal to 12A. Can we solve that? How? Say again? Here he goes dividing by A again. Oh, yeah. Tell him. Never mind. Huh? Subtract 12A from both sides. And that gives us A squared minus 12A is equal to 0. That's what we want. Anytime you have a polynomial with degree greater than 1, you want everything on one side, 0 on the other side. Now what do we do? Factor. And what does that give us? A times A minus 12 equal 0. Okay? Now what? Either A is equal to 0 or A minus 12 is equal to 0, which would give you, say again, add 12 to both sides, and that would give you A equal 12. Okay? Now, guess what? Your technique would have worked perfectly this time, dividing by A. And here's why. How many squares can you draw with 0 sides? None! There is no square. There's no length on the side. So this is a meaningless answer. So that one we could have divided by A because we're not going to allow A to be 0 anyway. So if A is equal to 12, let's see. What's the area of the square of side 12? Area of a square with side 12. 144. Okay? And then what's 3 times 4 times 12? 3 times 4 is? It's 144 also. 3 times 4 is 12. 12 is 12. 12 times 12 is 144. So sure enough, that's right. That wasn't bad. That was almost fun, wasn't it? Don't skip your word problems. If I'm your boss, that's all I'm going to give you. Hey, solve this problem, Figure out an answer to this. Okay? Let's see what they do. Okay? Oh, shame on them. They let such a silly letter. They let S be. Who cares what the letter is? That S represents the length of the side. They drew the picture and they put the S's there, just like we did for A's. Their picture's almost as pretty as mine too, Never mind. Okay? The area is represented by S times S, length times width, so it's S squared. Perimeter is represented by 4S. Walking around that, you walk a total of 4S units. And then the equation, the sentence there, says the area, S squared, is equal to 3 times the perimeter, 3 times 4S. So there's your equation. Just a direct translation of English to algebra. Y'all know that. You know algebra, you know English. Translate, okay? Now we solve that. S squared is equal to 12S. We use days, but it works the same. Subtracted 12S from both sides. Factored it. S times S minus 12 is equal to 0. So either S equals 0 or S equals 12. Well, guess what? S equals 0 is not a reasonable solution because it's not a square at all. There's nothing there. No length. So it must be a 12 by 12 parameter. I mean, a square. So, obvious. Oh, that must be your solution. All right. There is an example 12. Let's see if we can get that one done. Okay. Okay. Suppose the volume of a right circular cylinder, I abbreviate like crazy, of a right circular cylinder, okay, is numerically, okay, that's numerically, by the way, equal to the total surface area of the cylinder. Making fun. Okay, I hear you. Okay. If the height Yeah, I can hear them making fun out loud now. They weren't mumbling, and now they're doing it out loud. Yeah, you're really hurting me badly. Okay. Okay. That's why it's a good idea to bring your book. You can read it from the book and not make fun of me, okay? All right. If the height of the cylinder, okay, if the height of the cylinder is equal to the length of a radius, you've already given up and gone home. Okay, of the base, find the height. Guess what the first thing you're going to do? What's the first thing we did on the last one? Say again? Draw a picture! Way to go! Okay? I actually had a physics professor at UAB. I was taking quantum mechanics, so you couldn't really draw many of that, but he told us that in his sophomore level physics class, if a student did not draw a picture for the problem, whether they got it right or not, they lost half the points. He insisted you draw pictures. Now, I'm not that bad, or that good, or whatever, but anyway, let's draw a picture. Does anyone know what a right circular cylinder is? It's a tin can, okay? It's a circular base, and it has a height. Okay, that's a pretty ugly one. That's what a right circular cylinder is, okay? Now, I didn't draw it very well, obviously, but let's take the second part of this thing. If the height of the cylinder is equal to the length of the radius of the base, find the height. So let's do that. What is the height, you reckon? How tall the can is. So this is the height, okay? Is H okay to call it that? Yeah. Okay. The radius of the base would be, the base is a circle. So there's the radius. So this is saying H is equal to R, right? That's what that sentence says. If the height of the cylinder is equal to the length of the radius, if H is equal to R. Okay. So there's h equal r. What are we looking for? H, the height. You got it. Okay. So now let's go back to the first part. The volume, okay, I had to figure out what that says. The volume of a right circular cylinder. What in the world is the volume of a right circular cylinder? Say again? Base times height. You're absolutely right. It's the area of the base times the height. What is the base of that? Say again? No, the radius isn't the base. What is the base of it? A circle. Exactly. What's the area of a circle? Say again? Okay, that's in there. Well, you don't have to spell it out. I mean, do the number. What is the area of a circle? Say again? Pi times the radius squared. Did I hear that right? Pi r squared. I always thought pi were round, but no, pi r squared. Okay, never mind. That's a different issue. Okay, now, so the area of the base, we're going to call that let's call it A sub B. Area of the base is equal to pi r squared. But guess what r is? Yes, but what does this tell us? It's also the height. So we could say that's also pi h squared because they're the same length, right? So there's the area of the base. And then what do we say the volume was? The area of the base times the height. What's the height? H. So the volume of the right circular cylinder is pi r squared h, which is pi h cubed, because r squared is equal to h squared. So it's pi h squared. Okay? So there's the area, volume of the right circular cylinder. Is numerically equal to, this is equal to, equal sign, right? The total surface area of the cylinder. What in the world is the surface area of that cylinder? The what?
The whole thing.
What the whole thing? The outside, the surface area. Okay. Now that surface area is made up of two circles, and we've already determined the area of those circles is pi r squared, right? Or pi h squared. You got two of them, so the surface area is two parts. The first part is the top and the bottom. That's 2 pi h squared. But you also have the sides, right? How are we going to figure that? Well, what we do is get us a pair of 10 snips, okay? Well, first we get our can opener and cut out the top and cut out the bottom. That's the 2 pi h squared, right? Those two areas, right? Okay, now we've just got the sides. So I take our 10 snips and cut up the side and lay it flat. Make sense? What do you have then? Not a square. A rectangle. Very good. Okay, that rectangle, when we lay it flat, is like this. Okay? And what is this length? Don't be shaking your head. What is that length? The height. That's the height. You just cut up the side. That's the width of the thing. That height, you just flattened it out. Now, what is this length? Yeah, it's the width of that, but what is it? Not the radius. It's the. What about the circle? What? Circumference of the circle. Does anyone know what the circumference of a circle is? Say again? Pi d, exactly. Except we don't have a d here. How does d relate to any of the other things on the board?
The radius.
Okay, how does it relate to the radius? The diameter is related to the radius how? Say again? The radius is half the diameter. Exactly. So that means the diameter is twice the radius, right? So pi times 2 pi r. Circumference of the circle, that's the distance around. Circumference is equal to 2 pi r. Pi d or 2 pi r. But r is what? H. So this is 2 pi h. So the length of this rectangle is 2 pi h. The width is h. So what's the surface area of that? I'm going to call that the lateral surface. What is that? Area of, say again? Area of a rectangle. Length times width. The length is 2 pi h times h. That would be 2 pi h squared, right? I know we're running short of time here. Y'all checked out a few minutes ago, didn't you? Okay, never mind. All right, so the total area is your 2 pi h squared plus 2 pi h squared. The two top and bottom is 2 pi h squared, and the surface area, the lateral area is 2 pi h squared. Yes. Everybody see it? So guess what that adds to? 2 pi h squared plus 2 pi h squared is? Okay, don't worry about that. What's 2 pi h squared plus 2 pi h squared? 4 pi h squared. Now we have an equation. Okay? Here's the equation. On the left-hand side, we have pi h cubed is equal to 4 pi h squared. You see it? This side was the volume. The base times the height, that's pi h squared, is equal to, numerically equal to, the sum of these two, which is 4 pi h squared. There's our equation. How do you think we're going to solve that?
Make it 0.
Say again? Make it 0. How do we make it 0? Okay, let's subtract 4 pi h squared from both sides. Okay, and what does that give us? Pi h cubed minus 4 pi h squared is equal to 0. I like that. Now what do we do? Factor out a pi h squared. What's left? H minus 4. Okay, and that's equal to 0. All right, so that gives us two equations. Either pi h squared is equal to 0, or h minus 4 is equal to 0. Now, someone's been telling me what pi is, right? Some number, 3.14, blah, 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 okay, right? Now, you can divide that by both sides because that's not 0. You lose the pi. That's why we didn't even worry about what its value was. That means the h squared is equal to 0. What's the only possibility there? For h squared to be 0, what must h be? 0. That's not much of a tin can, is it? I don't want any spaghetti from that tin can, okay? At all, because nothing's in there. So we're going to ignore that. What does this tell you? H is equal to 4. That is, and that's for your radius equal 4. But all we're interested in is find the height, 4 units, whatever they were. Inches, meters, whatever it was, it's 4. And you see, that's what they got. And for some reason, they used R's rather than H's. It asked for H. Why didn't we change the H? They did R's and then said, well, R is equal to H, so that must be 4 units. We have now finished section 3.4. There's a concept quiz at the end of every section. These are true-false questions. I'm not ever going to ask you true-false, I don't think, ever on a test. But it's still not a bad idea to think through these, see if you can figure out if they're true or false and why. And guess what? Go to one page over and they have the answers. So you can see if you got them right. Okay? A good practice mental exercise to do. Okay? Your problem set, your homework though, do either 1 or 3 or both. If you find out that would be helpful for you to do them both. Okay? Then do any of the odds 5 through 41. There's a whole bunch of them there. I'm not saying you have to do them all, but do some of the easy ones. And if you got all those down, skip and do some that are a little bit harder. If you can't do those, back up some. You know, do as many as it takes for you to say, yes, I understand these. 5 through 41. This is on page 150. What's that? I can't hear.
Just the homework Monday.
What's that? Exactly. And I'm saying you can still do them. If you didn't get them done for today, you can still do them. I'll let you do your homework later if you want to, because I don't take it up anyway. All right, hey, that's not all, folks. Okay? Then do any of the odds, 43 to 63. Did I give those Monday? Probably. So do them. If you haven't done them by today, you still can do them. And then do any of the odds, 65 to 79. I bet you I didn't give those on Monday. Huh? 65 to 79, any of the odds. Okay? Then do any of the odds, 81 through 85. Okay? Then do any of the odds, 87 to 95. Okay? I will do a few of each group to make sure you understand them. If you can't get it, try a different. Yes. So, what if I have the third edition? I can't hear. Ninth edition. Say again. If you do the odds and that, they're not much different. They may not have the same numbers. Do them. The answers are in the back of the book. There's nothing special about any problem over the other, but do any of the odds in each group. So you feel like, oh, I got this. It's good enough to say, yes, I got it. Okay? Sure. Thank you. Already a paper in. Do you want me to activate that? Okay, I'll have to figure out how to do that. Is the web assignment? If you like doing that, I won't make any assignments on it, but you can certainly use that if you want additional.
And it'll be teaching the same thing you're teaching, right?
I'm sorry.
You'll be teaching the same thing.
Yeah.
Okay, so that'll help me like study for it.
Yes, exactly. Okay. It'll take me a while to do that. I'll probably get with Dr. Thomas this afternoon to make sure I can get that done. I usually